our last speaker today is Mr. Michael Naylor. He's the MD and CEO of EV Metals Group. He demonstrates experience. He's over 35 years of experience in management and development across mineral resources, finance, processing, technology in lithium, nickel, cobalt, chromium, manganese, gold and platinum. Covered a lot there. In Australia and both in South Africa. So he's led the acquisition and reconsolidation of the World Range complex commencing and has managed the evaluation of the Range World mineral resources since 2009. That was comprising the Ausinox stainless steel alloy project, the Range World MHP project and the battery chemicals complex. Mr. Naylor has also been a director and CEO of EVM Nickel since 2010 and CEO of EV Metals Group since 2015. And he was formerly the director and CEO of Podium Minerals. Please welcome Michael.
Firstly, I'd like to thank Bill Rapard and the team at Paydirt for the opportunity to speak today. I would like to give you a perspective on the nickel industry, but work back from downstream. So with EV Metals Group, we're building a global battery materials and technology business. And by battery materials, we have a strategy based on integration of the supply chain from metal in the ground through to the terminal market as we see it, and that is cathode active materials. In the case of nickel, there'll be high nickel for high energy density cathode active materials. I'd like to start there as well to also emphasize that battery materials supply chains require at that end of the business battery materials technology. And I'll outline some of our initiatives in that area this afternoon. So to begin, our company's focused on I'll change the slides. Our company's focused on the production of high purity chemicals and cathode active materials required for rechargeable lithium-ion batteries and in electric vehicles and renewable energy storage. And we, earlier this year, moved and entered into strategic agreements to acquire the global assets of Johnson Matthey's battery materials and technology business. That acquisition brought to our company, firstly, a portfolio of intellectual property rights, that is patents, licenses, know-how, and in particular, over 100 people that have developed the battery materials and technology business of Johnson Matthey over the last 8 to 10 years. With that, the assets include a state-of-the-art and world-leading battery technology centre at Oxford, where we make batteries. They make the cathode active materials that go into the batteries, and those batteries are used for test work with electric vehicle manufacturers. It's a strategic part of the business. Cathode active materials are not a commodity, and they're not uniform. You can look at, for example, I've heard speakers talk about the dominant cathode chemistry for high energy density cathodes is NMC811. Call that nickel, manganese, cobalt, 8 parts nickel, 1 part cobalt, 1 part manganese. But be clear, you might have the same chemical composition in those ratios in a cathode active material, but it will be different to another cathode active material with the same ratio. And why? It's about the particle shape, it's about the particle size, it's about the geometry and the architecture of the cathode active material as it's laid on the cathode. And the electric vehicle manufacturers have very specific requirements for that, and hence this technology centre actually works as a technology partner with the electric vehicle manufacturer to develop those cathode active materials. The other, of course, is the lower energy density lithium ferrous phosphate, LFP as we call it, and variants on that. We acquired the Battery Technology Centre of Johnson Matthey at Moosburg, just out of Munich in Germany. That is a world-leading battery technology centre. It pioneered LFP. The Chinese obviously had access to it, and of course, these days LFP is a very large part of the cathode active materials production of China. There are variants on LFP. we see higher energy density cathode active material coming forward in the form of lithium manganese ferrous phosphate, LMFP as we call it, which will have application in commercial vehicles both in Europe and the United States. But our focus today is nickel, and I'll hope I get to a point in this presentation. The Billingham Battery Technology Centre is a huge and strategic battery technology centre with a very large pilot plant facility. That facility was used by Johnson Matthey to develop a proprietary cathode active material, high nickel. It's called ELNO. It's a lithium nickel oxide. It contains about 93% nickel. Be clear, the trend in high energy density cathode active materials is towards thrifting out cobalt. It will be used, but it's a very important part of the high energy density cathode active material, but we see trends in those cathode active materials where cobalt is removed. And for example, your mid-nickel cathode active materials are now looking like lithium manganese nickel oxide, LMNO. And again, we're seeing demand for mid to high nickel cathode active materials. So the message to you is that nickel has a huge future in the electric vehicle industry, and in particular high to mid energy density batteries. There we go. The acquisition of Johnson Matthey's global battery materials and technology business shifts the focus of our company to the UK and in particular growth markets in Europe. This slide shows you the massive build-out of battery cell manufacturing capacity in Europe. I think, just keep that in mind as we have a look at the cathode active materials plants that are planned in that region. This slide shows you the demand for cathode active materials in the UK and in Europe. You'll see that in Europe, by 2030, the forecast demand for cathode active materials is approaching 150,000 tonnes per annum. You'll see that the dominant cathode chemistry there is your mid to high nickel cathode active materials. You'll also see that as we move forward, the market share of LMFP, or rather LFP, will increase to around 25 to 30% of demand by 2030. On the right-hand side, which is a market that very much interests us, that's the United Kingdom, they'll have a forecast demand for about 140,000 tonnes of cathode active materials by 2030. They don't have a CAM plant yet. And I think the next slide probably says it all. There's the current planned in production or under construction cathode active materials plants in Europe. There is no way that there are sufficient cathode active materials production facilities in Europe to satisfy that demand in Europe by 2030. To give you some insight to a cathode active materials plant, they typically build in modules of 30,000 tonnes per annum and usually have 3 trains of about 10,000 tonnes per annum per train. They come at a cost of 500 million. If you look at the next slide, you'll see that by 2030, the forecast shortfall in cathode active materials in Europe is approximately 600,000 tonnes. If you're looking at 30,000 tonne per annum plants, you need 20 times 500 million. It gives you some insight to the capital investment required in this business. The right-hand slide will show you exactly what the mix of the cathode active materials will be going out to 2030. Importantly, mid to high nickel cathode active materials is where the demand is coming from. We don't see that changing. This is a really important slide. I think the message to take away from this slide is Australia drill to find and develop nickel, drill and find and develop lithium. What this is showing is the capacity of each of the regions, namely Europe and North America, in particular the upstream capacity, midstream capacity and downstream capacity. Take a look at Europe. You'll see that they have a 90% deficit, or 90% of their forecast demand in midstream, and they have very little resources. The big opportunity for Australia is I think emerging though through the Inflation Reduction Act. We did our strategic planning conference in about June this year. We mapped out future worlds that address globalisation. We will not see the world reset to globalisation that we saw before the Russian invasion of the Ukraine. What we're going to see are future worlds where you have geopolitical alignment of supply chains, and there will be with that what we call resource nationalism, but equally importantly, industrial nationalism. What this shows for us, for Australia, very strong links between the US and Australia, and that the US should be looking to Australia to develop the supply chains they require to build out their midstream and downstream capacity in the US. Again, if we look at the North American market, it's showing similar trends to what has occurred in Europe. Massive build-out of battery cell manufacturing capacity, but nowhere near the capacity to supply from midstream and upstream the cathode active materials for those battery cell manufacturing plants. Here we take a look at the carbon footprint for producing nickel. We are heading to a future world where we will have to account for the carbon emissions in everything that we do, from the metal in the ground through to the cathode active material that you deliver to the battery cell manufacturer, and of course that battery cell manufacturer into your electric vehicle. The real challenge for the Western world and Western economies is that when you look at the Inflation Reduction Act, putting a spotlight, if you like, or put it another way, a microscope on the composition of the materials in battery cells, it's going to be traced. And today, over 80% of global midstream processing capacity for lithium, nickel, cobalt and manganese exists in China. It's even higher in cathode active materials. That said, again, the opportunities, I think, emerge for supply chains, for example, from Australia, to actually supply the demand that's going to emerge in the United States with that Inflation Reduction Act. This also leads to a comment. Up till about June or July this year, we thought that we were seeing actually substantial structural deficits in the supply of nickel moving out past 28-30. We've reviewed our view on that. I know there are commentators that are forecasting substantial shortfalls or structural deficits in nickel going out past 2030. I think you need to take a step back and have a look at what is happening in Indonesia. The production of nickel out of Indonesia is being pushed from both nickel pig iron and the conversion of nickel pig iron to nickel matte. With that, there is a huge growth in nickel that's going to come from that market. It will feed the Chinese stainless steel industry, but equally importantly feed nickel sulfate and similar metals into their battery cell manufacturing plants. With that, there is going to, as we see it, and our friends at Trafigura have given us, I think, very interesting insights to this. What emerges are two products, a product we call dirty nickel and a product we call clean nickel. And dirty nickel is a nickel that's produced with a very high carbon footprint. Again, this slide shows you that production of ferronickel has a carbon emissions reading which of course is eclipsed by the production of nickel pig iron. And then we look at high pressure acid leach. We're starting to see the carbon footprint of that process technology fall. What's interesting, the integrated sulfide via matte, I think really refers to sulfide nickel deposits, which I think we all agree are probably the best nickel deposit to work with. The challenge for us, of course, in global markets is there aren't enough projects to supply the demand for nickel. So we see a huge future for mixed hydroxide product. And I'll be very quick because with that, I'd like just to give you some insight to our company. Our business is based on integrating our battery materials supply chains, starting with supply chains from Western Australia. They are nickel and lithium, and of course the metals that go with nickel. From there, I'll take us to our resource base. I'm very proud to say that we have in our company tonight, or rather today, Ian Mulholland. For what it's worth, and it's worth a lot to us, Ian was the last person with his team that put a hole into our nickel laterite deposit, and I have no problem saying that, at Rangewell back in, I think, 2002, Ian. He was the first person to put a hole in it 20 years later. I think Ian's completed about 50,000 metres of drilling, taking our resource through taking our resource through to about 353 million tonnes at about 0.64% nickel, about 0.04% cobalt, about 0.3% manganese, and correct me if I'm wrong, Ian, but going with that, of course, is a nickel team. We think we have the best nickel processing team in the country. We also happen to have the best lithium processing team in the country. We are currently 80% through feed of the first 2 trains of lithium hydroxide monohydrate that will go into our nickel chemicals plant in the nickel chemicals complex in the Kingdom of Saudi Arabia. That complex is the world's first integrated battery chemicals complex, comprising lithium chemicals plant, a nickel chemicals plant, and we'll put precursor cathode active materials and CAM facilities into that as well. To give you some sense of size, we have 4 trains planned. The first 2 trains cost $1.3 billion, and we're being pushed to go to 6 trains going out past 2030. In addition, the MHP project at Rangewell is designed to produce approximately 170,000 tonnes of mixed hydroxide precipitate a year. That will feed the nickel chemicals plant. There are 3 trains there. With the same capacity, they will have an output of about 150,000 tonnes of nickel sulphate per annum. And to give you some sense of what that looks like, it's 3 times the size of Kwinana. Thank you very much.